All right, number 39 says the half-life of a radioactive element. We want to know how much is going to be there in 20 years if there was an initial starting point of 500 grams. So here's 500 grams. Here's the half-life. 20 is after 20 years, but the half-life is 21.7. So therefore, we divide those two because the time period is 21.7 and 20 is not quite getting 1, right? It's not one time period. It's a little bit less. So we raise 1/2 to that slightly less than 1 power, and then we'll multiply by 500, and so that our answer is actually in go formative. So I'm going to just lead you to that because it's getting late. B, here they want to know when, given this half-life, when is 500 grams going to equal 400 grams? This is the setup. That's it. So you want to solve for t. You would divide by 500, take the log of both sides. Divide by the log of 0.5 or the log of 1/2. Then you will multiply by 21.7. Okay? So I'm going to let you figure the rest out knowing that the answer is in go formative. Alright? Alright, 40. Alright, 40 says, now this is a really good problem because you start off with 100 gram, is it gram? No, it's not grams, that's too much. Milliliters, 100 milligrams. Okay. So you start off with 100 milligrams, but it loses 20% each hour. Now that means that it retains, it still has 80% after 1 hour. Okay? So since it retains 80% every hour, we want to know when is it going to equal 20, because if there's 20 milligrams in the bloodstream, that's when we have to re-administer it. All right? So we would divide by 100. We'd get 0.2. Take the log of both sides. The log of 0.2 divided by the log of 0.8. Whatever that is, that's your answer. And you can go into go formative, type it in, make sure that you get it. Okay, and that's it. Oh my God, I'm so tired. Have a good night. Keep studying. It's 10 o'clock. Go for it. Give yourself 2 more hours to study. It's a good idea.